functions with you in some word problem style. Again, you can find everything at www.cimath.com. And also, I'm going to give you some practice work to do that'll be due sometime next week on Castle Learning. So if you're one of my students, you can log on to Castle Learning, go to your account, and you will be able to get all of that practice based on the stuff that we've been working on the last few days. If you are not my student, and I see I've picked up a few of you, and you would like to do, good afternoon, Wilfredo, and you would like to do some of this, then again, get on the remind and then shoot me your name and hi, Emmanuel. Shoot me your name and your ID number, and I'll be able to add you to the Castle Learning, and then you'll be able to work on that stuff as well. Hi, Isaiah. So again, and then if you want to find my remind code, cimath.com, and you can sign up for the remind through there. Okay. So with that being said, let's get through this. Today's going to be a really quick, easy day. Hi, Kimberly, based on the stuff we were working on yesterday. So yesterday when we were going over exponential functions, I was giving you questions, and we were using that based on this formula. Okay, so let's see what we remember. The A represents the initial value. The percent, that's the obvious one, that's just a percent. And then your X represents your time, okay? And, oh, I see the video is not working. We can't stop it and go back. Then, the plus or minus here, remember that the plus refers to a growth, and the minus would refer to a decay. So there you go there. And then, so we're going to use this today to answer a few word problems. Okay. Welcome back, Jose. So here we go. Let's read the first one. Kathy plans to purchase a car. I know, the camera, I closed the computer before, and then I reopened it, and then realized the camera didn't go back on. And I don't want to stop it and redo it. So unfortunately, you guys will not be able to be graced with my beauty today. But if you really do want to see it, you can go to one of the algebra and geometry videos, and you'll see what I look like today. So Kathy plans to purchase a car that depreciates or loses value at a rate of 14% per year. The initial cost of the car is $21,000. It says which, but we're going to write an equation and solve the value of the car after 3 years. Okay. So if we, again, write down our formula, the more you write it down, the easier it is to remember. And then we're just going to plug in from here. A represents our initial value, which they told us was 21,000. Then we're going to have a 1. Now we have to decide are we going to add or subtract. Now the question said that we are going to lose value, so we are going to subtract. And then we're going to say the percent was 14, and it's over 100. And now what was our time? Loses value after 3 years, so 3 goes there. So now let's go and try and solve this. Again, as we were talking about yesterday, don't be so eager to just throw it into your calculator, and we'll just kind of take this one step at a time. So the first thing is 14 divided by 100. Yes, that's always the formula you're going to use, okay? And you always know you're going to be using that formula because it's percent. And again, keep in mind, anytime they refer to a percent, it's going to be an exponential function. So that's going to be 0.14 to the 3, okay? 21,000, and then 1 minus 0.14, again, if you go over to your calculator. And now, if you don't have the calculator, if you go to CI Math, right on the home page, I have a link to a spot where you can get this exact calculator that I am using. And then that's going to give us a 0.86. So I'm going to go plug in my 0.86 here. And now we can solve, okay? So I'm going to put that into my calculator. So I'll do 21,000 parenthesis 0.86 to the third power. And there's the value of your car. Now, they said that you're going to do this, find the value of a car. It's money, it's cents, so you're going to have 0.176. We don't have 0.176 cents. Remember, cents is 2 decimal places, so it's really looking at the 17 or 17 cents. Now, we're going to leave it at 17 cents or raise it to 18 cents. Well, remember, the 6, 1, 2, 3, 4 leaves alone, and the 6 tells us to go up 1. So I'm going to write an answer of 13,357 and 18 cents. Yes, 18 cents. And there you go. All of the questions we're going to do from this point forward are going to just follow this model. Now, some of you might be saying, well, why can't I just store? I just put this whole thing in my calculator and it gave me the same answer. Yeah, that could work. Sure. I can send a reminder for the Castle Learning. Sure, a lot of this could work if you throw it right into your calculator right from here, but at times you might make a mistake, and you're less likely to make a mistake if you take your time and take it one step at a time. All right, so now let's look at another one. So Rhonda deposited $3,000 in an account in the Merrick National Bank. Okay, so this is where she started. And it earns a 4.2% interest compounded annually. That just means that each year it's going to grow. She made no deposits or withdrawals, which means she doesn't touch the money. Write an equation that can be used to find B, her account balance after T years. How much will it be in her account after 5 years? It's a percent. It's exponential. I'm going to use this formula. So now when it says to write an equation to find B. Right, so this is when things get a little weird. So I got to kind of make sure I pay attention. So B is probably her balance. She started with $3,000. Now interest could be a good thing or a bad thing. Kind of depends on how you look at it. Whether it's your student loan, which would be a bad thing, or if it's money in your bank, which could be a good thing. But either way, that money is going to be going up. So it's plus. The percent is 4.2 over 100. Now, technically, it's x. X represents years. Here, they're telling you 5. But for the literal part of the equation, I have to start with a t. Okay, so this is one part of the equation. Write the equation, then they told me to use b, and then they told me to use t. So here's my equation. Now they want me to solve it. So if I'm going to solve it now, do 4.2 divided by 100. It's not going to be 0.42, but 0.042. And then the time is going to be 5 years. 3,000, 1.042, that's adding the 1, to the 5th power. Let's go ahead, let's throw that into our calculator. So 3,000, 1.042 to the 5th power. And you are going to have $3,685, and I'm going to say 19 cents. Good afternoon, Clarissa. Happy Friday. Okay, and here we go. Last question, number 7. Jacob and Jessica are studying the spread of dandelions. Jacob discovers that the growth over t weeks can be defined by f of t equals 8 times 2 to the t power. Jessica finds that the growth function over t weeks is g equals 2 to the t plus 3. Calculate the number of dandelions that Jacob and Jessica will each have after 5 weeks. Okay? So now, the time is 5 weeks, and they told me that t is weeks. So for Jacob, who said it's 8 times 2 to the t, I would do 8 times 2 to the 5th power. And if I'm going to go to my calculator, I'm going to do 8 times 2 to the 5th power, 256. And then if I look at Jessica, and Jessica said 2t to plus 3, that would be 2 to the 5th power plus 3. Now, here is when we have to be really careful. If you have a new calculator, you'll be able to put it into your calculator and it's going to look just like that. Notice that the 3 and the 5 are not together. The plus 3 is not an exponent. If I was going to look at this in my calculator, okay, the calculator is only as smart as the person using it. If I wrote 2 to the 5th power plus 3, that is not what this is not what the calculator is, okay? That is not that. What the calculator thinks you just told it was to do 2 to the 8th power. The calculator thinks do 5 plus 3, okay? This is when parentheses come really in handy. What you have to do is you have to tell the calculator, well, first do 2 to the 5th power, and then add 3 to it. So when you are doing these questions, make sure, again, just like fractions, 9 times out of 10, if you don't put the fraction in parentheses, it'll give you the same answer. But there are times when it could mess you up. So it's always a good idea to put the parentheses or the exponent in parentheses. So when I go to put it in my calculator, this, watch, gives me 35. But if I did this, 2 to the 5th power plus 3, oh, it gave me the same answer. Oh, I've got to be careful. Now I just did all that for nothing. 2 to the 5th equals plus 3, 35. Everything I said, just keep in mind, because I'm going to show you that in a second. So based on the growth from both functions, explain the relationship between f of t and g of t. So now, this is where it's going to really kind of come into play. So they're asking me to kind of compare their two growths. We're going to graph it. So let's graph it. So if I go to y equals, first one was 8 times 2 to the x power. The other one said 2 to the x, plus 3. Okay, so that's the 2. Now if I go to the table, because they want me to compare the two, 8, 4, 16, 5, 32, 7. So this first one here is representing Jacob. And then this second one here is representing Jessica. So what I would say is that the growth of dandelions for Jacob is greater than the growth of dandelions for Jessica. Okay? The growth of dandelions for Jacob is greater than Jessica. All right, now let me show you this. Let me show you so you understand what I was trying to show you here. Let's go to the calculator. What happens if I put plus 3 all in parentheses and I go to the table? The numbers are exactly the same, okay? Those numbers are exactly the same. Now let me show you how that would look if it was in a question, or how they would write it in a question. 2 to the x plus 3, 2 to the x plus 3. This was the question we did, and this in my calculator looked like this. because the 3 is actually dropped down. But now look at this one. The whole x plus 3 is an exponent, so this whole x plus 3 has to go in parentheses. So make sure you're paying attention to how they write the question. If you want the entire thing to be up in an exponent, you better make sure you put it in parentheses. If you need them to drop down, then just this guy will stay in parentheses. Now, if you have the newer calculator, then yours will literally look like this or look like this. You would just have to hit the right arrow to drop down the little blinking cursor. So just kind of just be wary of those numbers, where those exponents are, whether on the top or the bottom. Okay, so that wraps up what we're doing. What is the difference between the G and the T? Good question. They're just giving you different names for them. So if you look at the question, they're saying f of t is going to be Jacob. G of t is going to be Jessica. So that's the whole reason that we learn the functions, because if I just said y equals 8 times 2 to the t, or y equals 2 to the t plus 3, they're the same. But when I give them a function name, then I'm just calling him the f function, or in this case it's Jacob, and G is just the one for Jessica. Okay, so that's all. Are you doing this on the weekend? No, we're not going to do it on the weekend. Weekends are weekend. We still have to have a little bit of a life. So basically what I want you to do is I want you to get on Castle Learning and I want you to practice this. Okay, I want you to go on Castle Learning. I want you to practice this. There's 12 questions, I think. Again, if you're not part of my class and I don't have you on Castle Learning and you really want to do it to practice a little bit more, then please just sign up for my Remind, send me your name and your ID number, and I can add you to the Castle Learning and give you those assignments as well. Okay, and the codes can be found at www.cimath.com. Okay, so I hope everyone has a really great weekend, and you guys try to stay away from people as much as possible, and let your friends know. Hit the subscribe button down below, like, leave a comment, and have